So we're now going to take a look at the next example, which can be found in my live lessons RxJava EX2 folder in my GitHub repository. And this example is one that's going to demonstrate some more sophisticated capabilities that are available with streams, RxJava, and Project Reactor in order to be able to download images from remote web servers in parallel. So now we're in the IntelliJ project for this particular example. And you'll see that this is a lot more interesting than the version that we looked at before that did the factorial processing, because it's showing off quite a bit more mechanisms. And the example is more interesting than simply doing factorial. In fact, what it's doing is it's showing how you can download images from different remote web servers using parallel streams, RxJava, and Project Reactor. And it's also going to demonstrate the performance of parallel streams and these other mechanisms, both with and without using the managed blocker mechanisms of Java fork join pool. And this mechanism is a very cool mechanism that's built into modern Java that makes it possible to automatically expand the number of threads that are used in this common pool of threads that comes with any implementation of modern Java. So we'll kind of see how that works as we get along here. So when we run this program, as you can see, let's see how we're doing. We're making a little progress. We start out with 10 cores available. These are hyper-threaded cores. So of course, they can really have more like 20 cores, 20 virtual cores available. And it starts by downloading images. You'll see as we get through this that the first set of downloads only uses 10 threads in the pool. And that's because it's not taking advantage of the fork join pool managed blocker interface that can automatically increase the number of threads in the pool when certain threads block. Later implementations of the same type of mechanism for downloading images will be able to use more threads. And we'll talk about that as we get a little further along. So that will continue to run in the background. It takes a while to do this because I have lots of images and they're rather large. So here you can see we're going to parse the command line arguments. Then we're going to run all the parallel streams tests. We're going to run all the RxJava tests. And we finish up by running the reactor tests. And then when we're all done, we'll see what the results are. So let's go ahead and start out first by taking a look at the streams tests. So as you can see, we're going to run several different variants of these tests, which show off several different capabilities that you get with Java streams. The first one we're going to do here is we're going to just test the default download behavior. And as you can see, that's going to use the number of threads that are available in the fork join pool without using the managed blocker mechanism, which increases the number of threads in the pool. So you can see we're only going to get a maximum of 10 threads here. You can also see that we're downloading and storing more than 10 images. We're storing 42 images. So what'll happen when we use the default behavior is after 10 images are in the process of being downloaded, and they take a while because they're rather large, then no other threads are going to be able to run, even though all the threads that are downloading images are blocked, and therefore the cores are idle. They're just waiting. So in fact, we can actually take better advantage, in the later versions, we'll take better advantage having more threads running the downloads in parallel. And therefore, even if something's blocked, something's able to make progress. So that's the very first thing we're going to do. And then we're going to test a couple of different adaptive mechanisms that are able to expand the number of threads that are available in the common fork join pool. One's going to use kind of the native naked mechanisms for doing managed blocker. That's called the MB version. And another uses something else we'll talk about called blocking task, which is a little wrapper that I wrote to encapsulate managed blocker so it's easier to program. And you can see here, we're going to run the parallel streams versions. We're going to pass in the different functions to run, and then we're going to keep track of whether we're logging things or not. So let's go ahead and take a look at run parallel streams. What the heck is that? That's a very clever little helper function, which first does garbage collection, then deletes all the downloaded images, because we don't want to have to we want to clean everything up before each run. And then we go ahead and we will run the test, depending whether we have logging turned on or not, and it'll tell us how long it takes to do the testing. and we pass in the method that does the actual work. So we'll take a look at that in a second. So that's basically what this stuff does. Here's what the test download streams method does. It takes the function to use, and it goes ahead and it gets the list of URLs. Let's go take a look at the list of URLs. The list of URLs is defined up here. You can see there's quite a number of these things. I think there's a total of 42. And these are all JPEG images that I've stored in a directory in my Vanderbilt website. And what this thing does is it goes ahead and it takes these names and it goes ahead and converts them to each of the strings to a URL up to the number that we're going to be processing. And then it returns the list of these URLs, and we can use those to process them. And you can poke around here if you want to see some clever ways of being able to process lists and so on using streams and regular expressions. So basically, we end up with a list of URLs. We then take that list of URLs that we want to download and we convert it into a parallel stream of URLs. So what that means is now we have a stream of URLs that are going to be mapped to the different threads that are running in the common fork join pool. And then what we do, all these threads are off running, and we go ahead and apply the map operation. And map is what's called an intermediate operation in Java Streams lingo. And we're going to apply this function. We pass this function in, and we'll take a look at those functions in a second. But this is generic code that's parameterized by the function we're applying. And after all the images are downloaded and stored, we're then going to collect the results into a list. And then we're done, and we can go ahead and print statistics about this particular run. So that all the different programs are going to do that, all the different streams tests. But now let's go ahead and take a look at the different algorithms that we're passing in as functions. So we have 3 different algorithms we pass in as functions: download and store image, download and store image MB for managed blocker, and download and store image BT, which stands for blocking task. So let's take a look at the simplest one, which is here. What this particular method does is it goes ahead and calls a helper method called download image, and it'll download the image from the website and then store it on the local device. So here's what download image does. It goes ahead and it uses this method called download content. And download content is just a little helper method that I wrote a long, long time ago that goes ahead and opens up a connection to a particular URL. And then it reads the contents of that URL into basically a buffer. And when it's all done, it goes ahead and returns the buffer. So we read this into a stream, and then we get it back as a byte array. So that's what comes back from this. So we take that and we convert that into something called an image, which is just a little helper class I wrote to deal with images. So we've got an image, download image returns an image, and then we turn around and store that image, and an image knows how to store itself. So if you take a look at the image class, you can see there's a method called store that makes a new file and writes the image to the output. So nothing too profound there, just a way to get stuff written to the disk, or to in my case, the solid state memory, solid state drive. Okay, so download and store image just downloads the image and stores it. It does nothing fancy schmancy with respect to increasing the number of threads in the common fork join pool. To see what that is, let's go ahead and take a look at download and store image MB. And this uses the Java fork join pool, or common fork join pool's managed blocker mechanism. And here's what it looks like. It's a little bit ugly because managed blocker is a little tough to write because it doesn't have good support for modern Java functional programming capabilities. It's a Java 7 mechanism, so it doesn't take advantage of modern Java functional programming. So here's what we do. We pass in a URL that we want to download and store. We create a new image array with one element. This is a very sleazy trick, but it works well for things like this. And what we do then is we go ahead and say fork join pool, call the manage block method. Manage block is this super cool method that will increase automatically the number of threads in the common fork join pool if a thread is going to block. So if a thread blocks, then the manage block method compensates for the blocking thread by spawning a new thread to use as part of the pool of threads that can then be used with the cores that are available to run. There are two methods that manage block is going to define. It's an interface. One of them is called block, and one of them is called is releasable. We're going to ignore is releasable in this case and just focus on block. So block is the method that's called when you have to block in order to make forward progress, which we do here. So what we're going to do here is we're going to go ahead and say, download the image into image sub 0. And we have to do this because of the way that Lambda expressions and anonymous types work in Java. So we have to do it this way, sadly. But what we do when we're all done down here is we go ahead and we say image sub 0, get the image that we stored in that one element array, and then go ahead and store yourself. So this is basically kind of using an anonymous implementation of the managed blocker interface. And that's why we have to do that. Somewhat sleazy trick. We don't have to do it, but there are other ways to do it. This is a clean way to do it if you know what you're doing. So that's the approach that uses managed blocker directly. It works well from a performance point of view, but it's kind of ugly to program. So the last approach we're going to use here is called download and store image BT. BT stands for blocking task. We'll see how that works in a second. And you can see what we do here is really cool. We go ahead and we say, all that code that we had before that was kind of ugly, we abstract all that away. We say blocking task, call in manage block, and then we pass in a Lambda expression. In this case, I think it's a supplier Lambda. And that will go ahead and run the download image method in the context of the call in manage block method, which, as we'll see in a moment, under the hood, abstracts away from the ugliness of programming with the managed block interface or managed blocker interface. So let's go ahead and take a look at blocking task call in managed block. Blocking task is just a good old helper class. You can read more about it here at this link on Stack Overflow. This is a variant of what was provided there. And blocking task has a static method called call in managed block. As you can see, it takes a supplier. It makes a local variable of a helper class, a nested helper class called supplier managed blocker. And that encapsulates the supplier reference. And then we go ahead and we say, hey, fork join pool, please apply the managed block compensation algorithm on this managed block local variable. And that abstracts away from all the details that we would otherwise have to write ourselves in an ugly, anonymous interclass-like way. And then the last thing we do is we say, hey, managed block, get the results. So let's go ahead and take a look at supplier managed blocker. Here's the supplier managed blocker class. You can see supplier managed blocker is a nested class or a static nested class, inner class. And it implements the managed blocker interface, which is defined by the fork join pool, has a couple of fields, has a supplier, a result, and a flag that keeps track whether we're done or not. The constructor just stashes the supplier away. And the block method, which is what's going to be called automatically by the underlying fork join pool managed block method on a managed blocker, just says, hey, supplier, compute whatever you've been told to compute, please. Store this thing into the result and set done to true, and then return true. And then get result just returns the result that was obtained from before. So much cleaner. This is a very helpful class you can reuse if you're ever going to be using managed blockers, which I strongly recommend you consider using when you're programming with modern Java, because they do a more adaptive job of dealing with threads and blocking operations. Okay, so that covered the implementation of Java parallel streams. And let's see how we're doing on performance. Still working away. Like I said, these are big files and they take a while to run. So hopefully they'll get done before we're done looking at all the code. So what we're going to do now is we're going to kind of wrap this discussion up, and we're going to turn our attention to the RX Java and Project Reactor implementations.